Welcome everybody to a very colourful chemistry lesson. You'll see why it's colourful shortly. Here's the title: Acids, Alkalis and Neutralization. Let's find out what you already know about acids. 15 seconds to write down what you know about acids and where we might find them. Time up. Acids are found in our normal everyday lives. There are acids in your kitchen, in your bathroom. You put acids on your skin, your hair, and you even find acid inside your body somewhere. I wonder if you know where. For your GCSE, it's important that you understand that acids are chemical substances that produce hydrogen ions in aqueous solution. Let's just pause there momentarily. Hydrogen ions can be written for short as a capital H with a superscript plus sign. Also, may not be familiar to you, is the term aqueous solution. All that means is the substance is dissolved in water. Quick game. We have 5 items on view: soap, orange, toothpaste, vinegar and bicarbonate of soda. Which of these do you think are acids? 10 seconds to decide. The correct answers are orange and vinegar. It is safe to handle these acids and even taste them. These are weak acids. So what do you think acids taste like? 10 seconds. Time up. Acids taste sour. Imagine that face you pull if you have lemon juice squeezed on your tongue. Something like that, because it's so sour. It's important to remember that not all acids are safe to consume or handle. Strong acids are harmful. They should not be handled or consumed. Examples of strong acid are hydrochloric acid, which is found in the stomach, sulfuric acid, which is found in car batteries, and nitric acid. All 3 of these strong acids are found in science laboratories. To every yin there is a yang, to every left there is a right, to every up there is a down. Many things in life have opposites. Acids also have opposites. The opposite of acids are alkalis. So write down what you know and where we might find alkalis. 15 seconds. Time up. Alkalis are also found in our normal everyday lives, e.g. in our foods, drinks, bathrooms and kitchens. Unlike acids that produce hydrogen ions, alkalis produce hydroxide ions in aqueous solution. Hydroxide ions are abbreviated to OH and then superscript minus. Quick game once again. Which of these products are alkalis? We have soap, toothpaste, orange and bicarbonate of soda. 10 seconds to decide. The correct answers are toothpaste, soap and bicarbonate of soda. These are known as weak alkalis and they are safe to handle. What do you think alkalis taste like? Remember, not all alkalis would be safe to consume. 10 seconds for you to think about what alkalis taste like. Alkalis taste soapy. However, as for the acids, strong alkalis are harmful and they should not be handled or consumed. They are just as dangerous as strong acids. Examples of strong alkalis are sodium hydroxide, bleach and ammonia. Time now for your first learning check. Question 1. Which of these substances is an acid? Bicarbonate of soda, soap or vinegar? 5 seconds. Answer vinegar. Question 2. Which ions are produced by alkalis in solution? Hydroxide ions, hydrogen ions or oxygen ions? 5 seconds. Alkalis produce hydroxide ions. Number 3. Which acid is found in the stomach? Sulfuric acid, nitric acid or hydrochloric acid? 5 seconds. The correct answer is hydrochloric acid. Now we need to know how to test a substance to find out whether it is acid or alkali. To do this, we use something called an indicator. The indicator you will come across the most often is called universal indicator, or UI for short. Universal indicator changes colour when the number of hydrogen ions in the solution changes. Strong acid will turn universal indicator red. Weak acid will change it to orange or yellow. Weak alkali will change the indicator to blue. Strong alkali will change the indicator to purple. However, if the substance is neither acidic nor alkaline, it will be perfectly in the middle, which we call neutral. Neutral substances change universal indicator to green. The pH scale relates to the number of hydrogen ions in a solution. The higher the concentration of hydrogen ions, the lower the pH number. Anything with a pH of 1 to 6 is acidic. If the pH is from 8 to 14, it is alkaline. And if it is exactly in the middle, pH 7, that is a neutral substance. Let's test you out then to see if you've understood the pH scale. The substances are listed on the left of the table. The pH number is given and you have to describe whether it's an acid or alkali and also if it is weak or strong. We'll do the first one together. Soda water, pH 6. This would be described as a very weak acid. Try to do the others by yourselves. 1 minute. And here are the answers. Carboxylic acid, pH 1, makes it a very strong acid. You certainly wouldn't want to be touching that with your bare hands. Soap, pH 8. This is a very weak alkali. That's good news. Washing soda, pH 10, weak alkali. Stomach acid, pH 2, strong acid. Fortunately, it's safely contained in the mucus-coated lining of our stomachs. Oven cleaner, pH 14. Oof, guys, you can't get any stronger than this alkali. Very strong indeed. And finally, vinegar, pH 4, is a weak acid. Okay, are you ready for some practical work? I've been scouring the house for some suitable products for us to test to see whether they are acidic, alkaline or neutral. Now I just need my assistant. An assistant during lockdown. Who shall I choose today? Well, let's face it, I have no choice. It's going to have to be Mr. Jones, isn't it? Look at him. He's doing his hair. He thinks he's starring role. Are you ready? Right, since you're doing the dirty work, you'd better wear the science lab.
Oh.
The science lab coat.
Is it still wet?
You've no idea what we're doing, do you?
No idea.
No, okay. So we're going to be testing a range of household substances to see if they are acidic, alkaline or neutral.
Oh.
Okay, so we're going to start with one of your favourites, which is vinegar.
Oh.
So,
Have I got to eat it?
no, you don't eat or drink anything, please, in the science lab.
Ah.
A couple of drops of vinegar in there. I'd like you to add a drop of this indicator. It's called universal indicator.
Oh. Universal indicator.
And then describe what happens. Let's move that out of the way.
Oh, it's gone red.
It's gone red, hasn't it? Could you use that chart and tell us what that means if it's gone red? So this is acidic. It has a very low pH. It's gone red. Okay, you would have expected that from a vinegar. Right, choose another product. What do you want to do next?
I'll use this.
Ooh, be careful with that. It's oven cleaner.
Ah,
okay,
yeah.
so just put some into one of these little wells. Okay, add your indicator. He really should have had eye protection, but I failed to give him some. Okay, so hang on there, let it develop. What colour is this?
Ah, yeah, it's gone blue.
Ah, good. Does that mean it's acidic or alkaline?
Alkali. I'm going to squeeze some lemon.
Great.
In this. Yes. And this.
Yeah.
Ooh, oh, aye, red. It's gone red, look.
Yes, a bright red. So what does that tell us about lemon juice?
It is an acid.
Good, acidic, well done. Right, next one. Let's try some toothpaste. New tube.
Oh, it's going, that's alkaline.
Yes, it's like a greenish blue. So yeah, a weak alkali, definitely. Tea. A bit of tea. What do you predict?
I
Acid,
think this
alkaline, neutral.
alkaline. It can't be acid, can it? Tea.
Let's see.
Oh, it is.
It is. It's gone orange colour. Tea is actually tannic acid that it contains, so it is a weak acid. Right, very good. And the last one, because we haven't done this yet, and it's quite a crucial thing, water. So we'll just see what water is. This is not purified water, but it has been filtered.
Ooh, yellow. Acid.
Yeah, that's
How can water be acid?
That's somewhat unusual. Water should be neutral. Oh, curses. I have to rig that one. Oh, that was great fun. Hopefully my assistant is clearing up the kitchen while we continue the lesson. So we've learned about acids and alkalis and some examples of each, but how can we cancel an acid out or cancel an alkali out? Is there such a thing as neutralizing? Well, yes, there is. We simply call the process neutralization. If an acid and an alkali are mixed together, a neutralization reaction takes place, bringing the pH closer to 7. The hydroxide ions in the alkali are the chemical opposite of the hydrogen ions in the acid, so cancel them out. This will continue until the substance reaches pH 7, at which point neutralization will be complete. Yes, you're probably getting a bit of withdrawal symptoms because we've gone nearly a whole science lesson without an equation. Don't worry, there's one coming up now. Do not panic. This is a very simple equation. The chemical reaction between an acid and an alkali can be written as acid plus alkali produces a salt plus water. We can also write this as an ionic equation. H plus, then in brackets we put AQ to show that it is dissolved in water, plus OH gives H2O. The L in brackets here represents liquid phase. Water is a liquid. Bees versus wasps. Well, from a distance, they can look and sound alike, but the stings they produce are very different indeed. A bee sting is acidic, whereas a wasp sting is alkaline. How could you safely treat each type of sting? Time starts. Because a bee sting is acidic, that is an alkali to neutralise it. However, you do not want it to be a strong alkali because this would damage your skin. Examples of suitable substances would be a little bit of toothpaste or some bicarbonate of soda dissolved in water. However, a wasp sting is alkaline. Therefore, to neutralise a wasp sting, you would need a weak acid on your skin, something like orange juice, lemon juice or vinegar. Now it's time for our final learning check. It's called acid, neutral, alkali. So there will be a statement on the screen. You need to decide if it's true for acid, neutral or alkali substances. Number 1. pH of less than 7. 5 seconds. This is an acid. Number 2. Releases OH ions in aqueous solution. OH ions are hydroxide ions. 5 seconds. Correct answer is alkali. Next one. Pure water and alcohol are both this. 5 seconds. They are both neutral substances. Next, turns universal indicator blue. Acid, neutral or alkali? The answer is alkali. Taste sour. Acid, neutral or alkali? 5 seconds. Acid. Excellent, you've finished. I do hope you've learned a little bit more now about acids, alkalis and neutralization. See you next time.